Hey, 7th graders. This particular document is something extra. I did post it on Google Classroom. You don't have to have a copy of it, but I wanted to do a better job explaining slope to you. So, if you want, like I said, this document is going to be, you can access it on your Google Drive. If you want, you can just write in it through Notability or PDF Expert, or you can just follow along with me today and then go through it on your own for practice. It's totally up to you. This is not homework. This is just help. So the steepness of a line is called the slope. And we talked about that last Friday when I gave you that assignment, or that fill in the notes. So it says circle the line with the biggest slope. So the biggest slope is the steepest slope. So this one would be your biggest slope. The letter we use for slope is a lowercase m. You guys know this. Why? Because it comes from the French word monter, which means to climb or to rise. When given the graph of a line, we need to know a simple definition for slope. And that is that you need to do the rise over the run. Okay? And like I said on Friday, that's really important to remember and to always tell yourself, because it does get confusing when you are going from point to point on a graph. So slope is the ratio of a line's vertical change to its horizontal change. That's what we mean by rise over run. So we're going to do a few examples. Like I said, some of you guys might be totally fine. You don't need this, but it's a good refresher. So it says mark some points on the line. What you're looking for is where this line intersects the coordinate grid perfectly. So I'm just going to put a bunch of dots here so you guys can see where that is. Okay. Maybe I'll zoom in for a second. Can you see where they intersect perfectly? Like, it does not intersect perfectly right there. So you have to go on these dots. Okay. So it says start from the, and this is, I told some of you, this is how I do it. I start from the left, find the rise or the fall. So up is positive, down is negative. Okay, find the run. We will always run to the right. So in this particular case, I'm going to go up 1 over 2. Up 1 over 2. Okay, and that stands true for all these. They are all up 1 over 2. So later in this lesson, we will be using the formula to find slope. We often get fractions that need to be reduced. The images show 4 attempts at finding the slope of a line above. Can they all be correct? Well, if you look here, all 4 lines look the same, don't they? So this one, up 1 over 2, just like we did here. This one is up 2 over 4, but what is 2/4 reduced to? 1/2. This one is up 3 over 6. But what is 3/6 reduced to? 1/2. And the last one is up 4 to the right 8. What does that reduce to? 1/2. So it doesn't matter what 2 points you use on the line. If you pick the right points, they will all reduce to the same exact thing. Okay, so we are going to do some practice. It's just so you guys can just watch me. And I know from looking at this is going to be a negative slope. This is going to be a negative. This is going to be negative. These 3 are all going to be positive. And I know that just because they're going down from left to right. So the directions say the first thing is you want to find those nice points of intersection. So there's 1, here's 1, here's 1. So I'm going to go down 1, 2, 3 units and over 1, 2, 3, 4. So negative 3/4. The next one, this is a good intersection, this is a good intersection, this is a good intersection. So I am going to go up 1, 2, 3, 4 and over 1. So up 4, right 1. That can just reduce to 4. Next, here and here and here, up 2, right 1, 2, 3. Positive. Next one, these are all right next to each other, so down 1, so it's a negative 1 over 1, and that can just be reduced to negative 1. And this one, down 2, right 1, down 2, right 1, so down negative 2, right 1, and that can go to a negative 2. Last one here, up 1, right 3, so 1/3. Okay, so I've already told you guys this, but just recapping this, there are 4 different types of slope. As we travel left to right, kind of like you read a book, the graph goes up. So if they go up from left to right, it is going to be a positive slope. Okay, this graph is not steep at all, just like standing on a flat surface. So the type of slope is 0. There's no slope, there's no hill. As we travel left to right and the graph goes down, the type of slope is negative. This graph is so steep we can't even call it a slope, so it is undefined. And this will be the case for any type of horizontal or vertical line. Okay, so those are the 4 kinds of slope. Okay, so it says sometimes we are not given a graph, but instead we are given 2 points. And this is what I really didn't go into detail. This is what I was kind of saving for today. When this is the case, we must implement another definition of slope. And this is a slope formula. So we wrote this down in your notes, but we only practiced like 2 problems. Oops, that's Y1. Having trouble writing today. Or in other words, change in the y over change in the x. So let's find the slope of the line containing these 2 points. So I'm just going to rewrite my formula here. M equals y sub 2 minus y sub 1. These little numbers here, they are not exponents. You are not multiplying the variable by those numbers, but you are using them. This is what I do. x1, y1, x2, y2. That means that ordered pair, like the first ordered pair, the second ordered pair. So now we're going to use our formula. I'm going to put my y2 on the top. So m equals, then I have 3 minus 1 over x2 is 2 minus x1, which is negative 4. Okay, so remember 3 minus 1 is 2, and then remember on the bottom that when you subtract a negative, it really turns to addition. So this gives us 2 over 6, which reduces to 1/3. Okay, so these little images kind of explain what we just did. So by subtracting the y's, we did 3 minus 1. What you found was this distance right here. Okay, then by subtracting the x's, so 2 minus negative 4, what you were doing is you were counting how many over. 1, 2, 3, 4, 5, 6. And that's basically what you do when you count up and over on a graph. Okay, and so then what happens is this happens right here. You get your slope of 1/3. You just put them together. So before we start finding slopes, I'd like to just rewrite some of the weird fractions. So negative 3/9, this would be negative 1/3. The negative doesn't go anywhere, I just reduce it. 4/10, you can divide both those by 2, so you get 2/5. 4 over 1 can just go to 4. Negative 7 over 1 can go just to negative 7. When you have a negative and a negative, it switches to a positive. Negative 1 over negative 8 goes to 1/8. Negative 4/7. It doesn't matter if the negative's in the top or the bottom. It can go either place. Same thing here if it's in the bottom. You can just put it out in front. You can put it with a top number. It doesn't matter. 0 divided by 12 is 0. 0 divided by -2 is 0. But when you take and you try to divide by 0, this is where we get that undefined. Okay, so both of those are undefined. Okay, so now we're gonna, this is the last little part, we're gonna practice finding slope with the points. One thing that I do every single time is I label my points. x1, y1, x2, y2. And I know some of you, no offense, but are kind of lazy and don't like to do that. And I tell you, it makes a huge difference. So when I follow my formula up here, y2, my m, is going to equal 2 minus -1 over x2 is 6 minus x1 is 4. So remember that when you subtract a negative, this turns to adding. So 2 plus 1 is 3. 6 minus 4 is 2. And so 3/2 would be your answer. Do not switch it to 1 1/2. We don't want to deal with that for a slope. Because you're going to think about this. You're going to go up 3, right 2. So x1, y1, x2, y2. So I'm going to have 3 minus a -2 over 4 minus 3. So these turn to addition. It doesn't always work this way, just these problems. So 3 plus 2 is 5, and 4 minus 3 is 1. So your answer is just 5. x2, x1, y1, x2, y2, and guess what? It really doesn't matter which pair you call your 1s and which call your 2s as long as you stay consistent. So I'm going to have 12 minus 4 over -3 minus 0. 12 minus 4 is 8 over -3 minus 0 is -3. So it just stays -8 over 3. And that's your answer. So your next one, x1, y1, x2, y2. If you want, this would be a good place to practice. You could pause your video, do these 3 problems, and then check what I have going on. Check with them at the end to see if you did them right. So I'm going to have 1 minus 7 over -3 minus -1. 1 minus 7 turns out to be a -6. This turns to addition. -3 plus a +1 is a -2. Negative over negative turns to a positive. You can divide both these by 2, so it's 3 over 1, or just 3. Your next one, x1, y1, x2, y2. So we have 7 minus 7 on the top. Then on the bottom, I have -11 minus 3. 7 minus 7 is 0. -11 minus 3 is -14. 0 divided by anything is 0. Last one here, x1, y1, x2, y2. I have 10 minus 4 over -5 minus -5. Okay, 10 minus 4 is 6. Remember, subtracting a negative turns to addition. So this ends up being a 0. 0 divided by 6 is undefined. That would be a straight up and down line. Okay, so kind of a recap of what we did last Friday, just more in-depth notes. Like I said, those were all available for you on Google Classroom. I just posted a PDF. You can open that PDF and you can work on this slope assignment. You don't have to print it off. You can submit it back to me if you want feedback. You can ask me questions. But this is just something to give you extra practice. And then your IXL, your U, or is it U or Y, V2 maybe, V2, will be your assignment. So I hope that this made things more clear and you guys are able to get this done. If you have questions, send them my way.